Hey guys, happy Thursday. It is September 17th. The title of our lesson today is called Popcorn. Our do now was to look at this picture right here. And which zoom in model do you think best shows the particles in a kernel of popcorn and why? So this is model A, model B, and model C. Which one accurately or most accurately shows what popcorn kernel particles look like? I want you to, if you are doing this and you did not attend the live class, go ahead and pause the video and write, I think model blank is the best because right here on your version of this slide, that'll work. Okay, I'm going to keep going, but you're welcome to pause and do that. That always helps to do the do now on the slide, actually write it out, get your brain working, okay? Today, I'm going to share with you our sciences of the day. I'm going to do a little bit of review from yesterday's learning, Wednesday's learning. I'm going to have you guys, well, in class, we're going to break out. If you're not here in live class and you are doing this from home, and you did not attend the live class, I'm going to go through with you what I was going to have everyone else do, and you're going to have to do it by yourself. Now we'll go through the independent time where we are working on our models and practicing some vocabulary. So our scientist of the day is Dr. Moya McTeer. She is an American astrophysicist. That means she studies the physics of the universe. And she's also a folklorist, which means she studies folklore and like culture and stories that people tell in different cultures. She grew up in like a very rural place, in Pennsylvania in the mountains, in like a cabin with no cable TV, no internet. It was very different from where most of us live now. And she worked hard at school, and she was the first person to study. She went to Harvard, and at Harvard, she was the only first person to study both astrophysics and folklore and mythology. So she has like two majors. She studied the science of the stars and the physics of how they interact with each other and really complicated stuff, and like culture and history and mythology and stories that different cultures tell to explain things. It was very, very different, which is why she's the first person to do that. She has a PhD in astronomy. So after her degrees at Harvard, she went to Columbia University, which is also in New York, or actually in New York. Harvard's in Boston. And she now researches the way the Milky Way, which is the galaxy that we are in, how its rotation affects how planets are formed. Just like real astrophysics stuff, which is very cool. But so she loves talking to people because she's got this folklore stuff, right? She loves telling stories. She loves hearing other people's stories. And so if you visit her website or you check out her podcast, she loves going on podcasts and talking about science, talking to other people about other things. She's just out there a lot in media, which makes her somebody really interesting. That's actually the first way I heard from her. She was on a podcast I was listening to, and I went, oh, I want to know more about this person. And so now she's our scientist of the day. Okay, so I'm going to do for this slide. This is a slide that we worked on Wednesday, where I asked you to work on. So I want to just go over it with you real quick because I wasn't there to tell you what made sense. So this is a solid liquid gas. So what I hoped you guys did is actually drag this over and, oh shoot, there we go, solid. This is good. I want to make sure that these are all on top. So here's liquid. Let me drag that again. This one should be liquid. I'll have to delete that arrow. This one should be gas. Okay. Just so you know, this is basically on the research you did on Wednesday by yourself. Okay, describe what matter looks and acts like if you zoom in. Okay, so you can answer this a lot of different ways. Here's what I'm going to write. When you zoom in, matter is, I'll take the ellipses away, made of particles, atoms, and molecules. Those atoms and molecules are both particles. We'll learn more about what they are, what the difference between an atom and a molecule is, but they're both tiny, tiny, tiny little pieces, which are particles. And can act, so particles can act like little tiny ping pong balls, bouncing, moving, spreading, changing space. Yeah, so particles move, they get farther apart, they get closer together, they can move faster, they can move slower, they can bounce into things, these just like ping pong balls in that way. What is different about the different states of matter, about solids, liquids, and gases? We know particles in different states of matter have different amounts of energy. Some move at different speeds and have different spacings. I can say that. I can say that. See, this is good. This is what I want you guys to do. I want you to like this struggle. I wasn't even exactly sure what I wanted to say. They have different spacings. Some are closer together, like the solids. Some are farther apart, like the gases. Great. Okay, let's keep moving. I'm gonna turn this way. I'm happier that way. Okay. Here we go. Great. So in class, I'm gonna have everybody just watch this video. It's a couple minutes. It's a slow motion video of popcorn popping. I'm not gonna watch it. You're not gonna watch a video of watching a video. You're just gonna go to this slide and watch the video whenever you want. Okay. There's 30,000 frames per second, ultra slow motion. They take They take 30,000 frames every second, 30,000 tiny little pictures every second they're filming this thing, so that when they play it to you, they can spread those frames out and show you every little tiny change that happens. So it looks really slow, which is super cool. So what we're doing is thinking about observations. What do we actually see? And we're using this sentence starter, I observe. And we're going to have them write down. You're going to write down in your breakout rooms what you observe. Okay. You're also going to write down inferences. What do you think? Here are some things you should think about while you're watching this video, and watch it again. It's cool. What happens to the temperature of the kernel while the popcorn is popping? What is this gas? You see this little white gas here? What is that? Why do we see that? What is inside the kernel? Like just holding up a popcorn kernel, which I don't have in my hand, but pretend like I do. What's inside of it? How do particles change as you change the temperature of the kernel? At what point does the kernel actually pop? In general, we're trying to answer, why does popcorn pop? This slide we'll share out as a whole class. If you're doing this by yourself, don't rewrite it. Just write it on these two. That's cool. And here is your independent learning.